Hey coding buds, so basically in today's GFG POTD we have a problem, next element with greater frequency, and it is a medium wave problem, and the problem statement is given as given an array of integers for each element, find the closest element to the right that has higher frequencies than the current element. If no such element exists, return -1 for that position. So by reading this problem, I can say here this problem is like somewhere related to our previous problems which I've already solved at like 7th, or which I already solved on 7th of July 2025, and that question is like also depend on stack type of things, and in that one also we have to find the greatest frequencies, okay, for the right elements. So there also what we have to do, we have followed the stack data structures. Here we have to do the same thing for solving this problem, as this question is like asking for finding higher frequencies that is present in the right side. Okay, so we have to return basically in the initial we have to like set every value as -1 at the indices, and we have to return only those indices which is having higher frequencies, okay, at the right side. Okay, so like if I'm talking example one, here we have 2 1 1 3 2 1. So if I'm going to explain about this for this example, here for 2 the right element is like 1, and 1 is appearing for 3 times, that means 1 is having 3 frequencies, so here we have to return 1. Okay, then again if I'm going to talk about array of 1, that means here at index 1 we actually getting as 1, and the right side value is again 1, so we have to skip, we have to check for other elements, okay, which is like 3, and 3 is like appearing for only just one time, so here we return -1 for both the case. Okay, then again if I'm coming here, so if I'm checking for once I like once I check for let's say array of index 4, so for the right side we have again 2, and 2 is having frequency for 2 times, so we have to return 2, and for 1, and if I actually appear to 2, again we have like 1 which is appearing for 3 times, so again we have to return 1, and at the last index there is no any other element, so you have to return -1. Okay, so similarly here we have a second example. So we have to solve this one with an expected time complexity of order of n and expected auxiliary space of order n, and we have to solve this problem with by using hash and stack data structures. Okay, so let's try to solve this problem. So before solving, first of all, what is my approach to solve this given problem? Here here I've solved this example. Here I'm going to explain about the approach. Here this is the arrays element by the example one here, which is like in the form of like 2 1 1 3 2 1. Okay, and have created the stack by the initial -1. Okay, so first of all we have to, let's say, create unordered map. Okay, so first of all we have to define the size of an array, and then after that I have created here unordered map. Okay, unordered map, which is for finding the frequencies for the number. Okay, so here what I have to do, here I have to traverse it and counting the frequencies for each element. Okay, so for int I inside the array. Okay, then here I have to map of I plus plus. Okay, so here we can set it in our first step, or for solving this problem, it's like first of all we have to count the frequencies of the element or all the items. Okay, once we count these things, now once we have counted these things, I have to create a stack. Okay, so I have created the stack of integer type, as we have to store the value of integers. Okay, which we at the last, which we have to return it or modified our array. Okay, so here what we have to do, stack of int, let's say I have to define st, and for initial point we have to do st.push -1, that means here we have to fill every value as -1. Okay, now once you have like created our stack, now in our step second, now we need to check for next element with greater frequencies. Okay, with a greater frequency, and how we can do these things, So for that, here we have to traverse again. For int I is equal to, here we have to traverse it from the last. Okay, that means once at the last element from the list. Okay, that means point I is equal to n minus 1 and I is like greater than or equal to 0. Okay, and then I minus minus, as I also like solved it in the last example here. Okay, now here we have to check the condition while stack top is like not equal to -1, and we know currently every element which I have set it in a stack is like -1. So here I have like set our stack, I have created a stack, and for the initial point I have like stored every block of the stack as -1. Okay, so here I am like giving the condition while stack dot top is not equal to -1. So, and second condition like here to give another conditions which will be like, we can say that map of stack dot top. Okay, that means here we have to check inside the map. Okay, if map of stack dot top is less than or equal to, we can say that map of array of I, then here we have to just simply do one thing. Here we have to do stack dot pop. Okay, that means we have to remove from the stack, meaning I'm going to explain about this line here. Here, as in the initial point, I have like stored every value as -1 inside the stack, and here I'm just checking the conditions like if the stack the top is like not equal to -1. Okay, and inside our map of stack the top. Okay, that means the top element which is like less than array of I. Okay, that means it's having array of I which we can set, which is having less frequency than that. Then we have to just simply remove it, and we have to store it somewhere else. Okay, so here we have to do what? Here we have to, let's say, create int number type, which basically creates our top value. Okay, which we have to store. Okay, that means they have like higher frequencies. Okay, so here we have to do int num is equal to st dot top, and we have to push it inside our stack. Okay, our array of I that is having the higher frequencies. Okay, and then after that, what we have to do? Here we have to do array of is. Here to simply insert inside our, that means here to modify our array as our num point, which is basically the top positions of stack. Okay, so here we have to just simply return our array, which is like our modified array. Let's try to compile it. So yeah, here compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.